All right. Well, here we are. It looks like my camera is a little off. Let's fix that. I don't know if I can fix it. All right, whatever. We're back live on another Ziti TV. Greetings, everybody who might be out there, who might watch this later. Haven't done a stream for a little while, so it is about time again. And this week I thought is going to be particularly interesting because we did have a user in Discourse who showed up a long time ago, and they were looking to do some sort of bootstrapping of an OpenZiti overlay network entirely by themselves. And it looks like Ruslin's here. I believe that was you. Hello there. So today we're gonna check it out and see what he's done, and take a peek and see if I can follow it along. And let's see. We've got a brand new UI that I'm working through. So if I screw up the stream, it's because I got a brand new UI. And so this is what we're going to do. We're going to explore OpenZiti's PKI and take a look at the cool. Actually, let me get the URL and I'll put it in the chat here. Let's go over to not Dolly, but this URL. We'll put it in the chat, and we can even go one step further. If I can find where the banner comes from, where are the banners? Captions? Is it called captions? Add a caption. Add it, and then can I show it? Boom, just like that. I did it. Oh, I'm so proud of myself. Yeah, so out on GitHub, Nenkoru/OpenZiti, manual PKI. And so this is what we're going to be looking at. This is the entirety of today. But before we do that, oftentimes on Ziti TV, I will really read the release notes. I did mention the other stream not too long back. We do have an official 1.0 that came out. Let's go down and find the 1.0 release. Here's the 1.0 release. If you haven't checked out the let's get this off of here now. If you haven't checked out the 1.0 release, do check it out. A lot of good stuff came, and a lot more good stuff continues to come. In the meantime, from 1.0, there have been a bunch of pre-releases. So with the 1.0 release, OpenZiti has started to slow down the release schedule insofar as every single release doesn't produce a latest. So you can go out and get the pre-releases if you're interested. Each pre-release is kind of like an alpha or a beta, if you would. And they're not the official releases, but they are out there for lots of readmes, lots of release notes to go and read through. Let me bring up my chat again. All right, and so there's a 1.1. Let's actually look at 1.1. We've got some HA type stuff that happened in there, some issues that were fixed. Makes a lot of sense, a lot of bugs. Cool. Let's look at 1.1.1. Same sort of thing. HA Alpha 3. Release can be run in HA mode, still in alpha. Same sort of stuff. Oh, a new contributor call out. That's really cool. Let's see. 1.1.2. Bug fixes. Ooh, 1.1.3 has been marked latest. So we do have a new one. In here we have sticky terminator selection and Linux and Docker deployments log formats. Yeah, that was unfortunate change where we made a little modification and forgot that people might have built things to read, say, JSON and not that nice human readable text that us pesky humans like to read. Instead, JSON. So we put that back. Let's see. Stick terminator strategy. That's interesting. I wonder if it's supposed to be sticky. My imagination says it's supposed to be sticky. Let's see. This release, actually, let's make it bigger. Okay. This release introduces a little big. This release introduces a new terminator selection strategy called sticky. On every dial, it will retain a token to the dialer, which represents the terminator to be used in the dial. So basically, what this is trying to do. Those of us who have ever had to deal with load balancers and IP addresses and whitelists and all that sort of stuff, a lot of times when you whitelist something, you want everything to come back from the same IP address. Otherwise, it can be a problem. Generally with OpenZiti, you can do that with just regular policies and controlling where you offload your data from. However, if you have numerous routers at one location, or if you have something that ties a user's session to an IP address or something along those lines, you want the next session to come through the same IP. So, or maybe logging even. Logging would be another reason, right? You want to see all of the activity that this one session had. So you want all your dials to come from the same place. So with this new strategy, every time you dial a service, your egress will go to this. Well, if you egress the overlay, it'll all go to the same terminator, so that it makes sure that the IP address it comes from is the same. Now, in an SDK perspective, you can just make sure that you're always targeting the exact same one. So if there's a session on that particular, like maybe you have implemented your own HTTP server with your own HTTP session, and you have multiple applications deployed, multiple servers deployed, and you want that stickiness to come back to your HTTP server, you would use the sticky strategy. So that's cool. There's even a Go SDK example. You can fire that up and give it a try. Anyway, that's what's new in the release notes. So now let's get back into it and let's start looking at, I probably should, I mean, I could call out the discourse maybe. But this was the result of the discourse post. And there's a lot, I love it when a project has a README. Oh, by the way, if you're watching this and you haven't given this a star, go give that repo a star. I started it today as soon as I went there. Okay, manual bootstrapping of PKI for OpenZiti using openssl. So what this is really telling us, when you, let's take a little tangent and we'll go look at the OpenZiti doc. There are two ways to deploy OpenZiti. Well, two main sections, I guess. There's the quick start section, which was always meant to be sort of a quick and dirty, get yourself up and running, not really production, but totally works for production if you want to run it in production kind of thing. And for the longest time, that was all we had. And so there's a bunch of different ways that you can start a network out here. There's also, where's guides? Down here, deployments. So now in deployments, you'll find a bit more rigorous section. Here we have a package that you can install, and you can simply run a little bash command, or you can go through the process of configuring your particular Linux variant for the repository if you want to go through package managers. But we also have this section down here if you're not familiar. But both of these things we'll gloss over very, very quickly, is that OpenZiti maintains an entire PKI of its own on your behalf. And that's obviously pretty important to a zero trust overlay network. Let's go back to this particularly one, which has mutual TLS among all of its connections. Every single connection in an OpenZiti overlay is mutual TLS. So the connecting side must present a certificate. The receiving side must present a certificate. Those two must match up. And if they don't, and if they're not verifiable, then no connection is allowed to be established. Obviously, in a zero trust overlay that's built like that, you're going to need a PKI, or a public key infrastructure. And OpenZiti maintains that all for you. And that's great. Most people do not want to be bothered with PKI, but it is a cool learning opportunity. If you've never looked at PKI, I am no pro by any stretch of the imagination. I know enough to be really dangerous, which makes this fun. So you can call me out, tell me what I did wrong in the chat, all that sort of stuff would be great. But if you've never looked at PKI, and it's a little scary, people say, hey, don't invent your own cryptography, and people take that to the end, like, don't invent your own PKI, right? And people just don't want to screw it up. They don't want to mess it up. But some people are like, hey, I know everything there is to know about PKI, or within reason, and I want to maintain my entire PKI on my own. So when you run one of these quick starts, or when you run the deployment guide down here, you'll end up getting an entire PKI that's created on your behalf. OpenZiti manages it and maintains it. When you read our doc, it'll say, listen, if you're going to back this thing up, make sure you back up to PKI. And that's all well and good. But there's no reason that you can't use a thing called openssl. And if you've never heard of openssl, you can go to openssl.org, read all about it. Most likely you've SSH'd, if you're watching this and you know Ziti, you've probably SSH'd somewhere. When you use SSH, you're most likely using openssl. OpenSSL is used all over the place. Our tunneler is configured to be able to use openssl as its connection engine. What do you want to call it? TLS connection, factory engine, whatever you want to call it. A security layer. I don't know what the right word is. Anyway, it's a great project and comes with Linux. And so if you have Linux installed, or well, you might have to install it, but usually comes with Linux. So if you have a Linux variant, you probably have OpenSSL. So here's my Linux environment in Windows subsystem for Linux. You can type OpenSSL and you see all kinds of commands can be had. And so that's what we're going to be doing here, I believe. I've already taken a little preview through here, so I haven't seen the whole thing, so I'm kind of fresh and new at this. But this is what it's all about. All right, so that's a lot of preamble. Let's get more into reading the README and actually doing some stuff. Okay. Main objective, bootstrapping utilizing Ziti is to have security on the application level. Fantastic. So we got this user wants to actually embed OpenZiti into an application. That is, without a doubt, the end goal for OpenZiti. I wanted to try out something apart from the classic VPN. Sure. Let's see, where's my mouse? Fortinet. I saw these were all VPNs. Felt strange, my connectivity of mine. Yeah, yeah. Of course, I didn't have access to these systems, but I could have connectivity to them. This being a potential intruder could have it too, sure. And found OpenZiti. Cool. I've struggled to understand OpenZiti for quite some time. Understandable. It's a lot of new terminology. Most people out there who are doing this sort of stuff, they know what an IP address is, but you really do have to take a moment and understand some of the new concepts, particularly not so much zero trust, but particularly the OpenZiti ones. And then how does OpenZiti's terminology map into that zero trust world? Things like strong identities, things like least privilege. What does that actually mean? There's nothing in OpenZiti that says least privilege, right? In OpenZiti, you would find service policies, and service policies would define what identities have access to which services. And so by default, OpenZiti starts with no access. You have to add or grant or authorize every single interaction in OpenZiti. Some people also complain that that's a lot of effort. And, it is effort, but that's what it's all about, right? You're trying to minimize the amount of identities that can connect to other identities. And I don't say devices, I could say applications, but even an application could have more than one identity inside of it. A good example of that, EdgeX Foundry, is an IoT platform that I've been working on, trying to get OpenZiti into, and they have a developer UI, and that developer UI connects to multiple services, and every single service that UI connects to could technically have a different identity. So even application isn't necessarily granular enough. You could have an application like a server that has multiple identities inside of it. All right, I'm going on tangents here. All right, but the PKI was daunting and looked complicated. It is. Most people have already talked about that. It is definitely daunting and complicated. But like everything in life, once you understand how it works, it becomes a lot easier. All right, the tutorial didn't help much. Uses Ziti's sub app to create the whole PKI, which is not transparent as a learner. That's exactly right. The goal, just another tangent, the goal of the quick starts. So if you are new and you are learning Ziti and you do want to try to understand what OpenZiti does, is you go out to either the local no Docker or the host it anywhere. This is just easier because both of these will tell you to download. Where's the .sh? Right here. It'll tell you to download this .sh file and execute function called express install. And so if you are interested in going through, and this is most likely what Nengoro did, you can go through and see exactly what happens. And there's a create PKI function inside of here. And you can see exactly what OpenZiti does. It is quote unquote only one page, but there are subcommands in here and there's a lot of variables and a lot of stuff. And then you have to understand how OpenZiti is creating that PKI. It is all quite complicated. Let's see, there's an organization already bootstrapped, PKI. The private key for the CA is stored on an HSM. Very nice. Hardware security module for those who aren't familiar with HSMs. Take a look at what they are. Let's see, the controller node could be compromised. PKI, whole backstory, started my journey. I've made this PKI thoroughly, looking through this forum, 2 videos, as well as the from scratch. Ah, yes, the from scratch. That was a little script that I did which basically boils that quick start into all of its constituent pieces. And I believe it is even procedural. Like you should be able to set this and run the whole thing, and at the end, a network should pop out. You can see, set a whole bunch of variables up here. I haven't actually tried that, at least not in a while. So if it doesn't work anymore, you'll forgive me. All right. So let's see. And then no link, but I know I've seen Bootstrap. Is there a link? Yeah. Okay. We gotta get a little link on there for people who get to the bottom. Bootstrap PKI. And so this is like the main meat and potatoes. All right. Markdown should walk you through the steps takes to bootstrap to PKI. Let's see. To see the way the PKI is bootstrapped. All right. First thing I actually have to do, I have to clone this repository. So let's go out to here, clear, make dir Ziti TV, Ziti TV, git clone. Okay, I have cloned the repo. All right, create a self-signed root CA. So we're going to make a rec, a CSR request. CSR, I guess, is a certificate signing request, rec. X509, make it valid for 10 years. It's going to go into the PKI directory. And this is the reason why I cloned this, because nicely enough, there's already a PKI folder here for me to put this into, which is great. It's going to use whatever subject I want, my best org. I love it. And then output a root CA. And then it's going to use this extensions configuration, and then the v3ca key or an entry. I don't know what the right word is for that. Let's take a look at that real quick. And so here, there's an extensions conf, and there's a v3 underscore ca. And here's, you can get all this from the Ziti CLI too. You'll go in and see, but this is the key bits of information that you have to provide to openssl so that it'll make a certificate signing request, which is valid. And so it needs critical and then a CA of true. We're making the root CA in this step. Yep, self-signed root CA in this step. So obviously the CA constraint needs to be set. It needs to be able to sign data. So digital, actually this is digital signature. Yes, that allows you to sign data, and then CRL sign. So you need to be able to sign certificate requests, and then key cert sign. I don't know what that means. Let's see. Where is my ChatGPT? Maybe it'll tell me what these things are. Let's see if I can get that real quick. Go back to the old ChatGPT. Where was it? I'm pretty sure I had it describe me this earlier. Let's see. CRL signing and certificate signing. Okay, that's what key cert sign means. All right, great. And so let's go ahead and I think we should, yep, we can run it now. No DES. I don't remember what no DES stands for. All right, so when we're done, we should have a PKI root CA cert. And we do. Okay, so now we've made, oh, you know what? The other thing I forgot to mention that I thought was really great, and this is going to be useful, is here is a PNG that demonstrates what it is. I think what it is we're going to create, and it doesn't quite fit. Let's do, there it goes. Now it fits. Oh, and let's get V for video. Can I get out of it? Yeah, there it goes. All right. So we've just created the root CA up here. Next, we're going to make a intermediate CA, and then from there, we're going to make another intermediate CA. And this is cool. So this is infra. Would be, I assume, infrastructure, and then network would be everything related to the network. And so there's nothing demonstrated as being from this CA, but you could have other networks perhaps, or you could have other identities. The other one actually let's actually, let me get the old boop. Let's see, we got the other one actually shows what would be created. I made this one to show how it would look like in an organization. Aha, well, thank you for that. Let's look back at PKI topology. Ah, this was the one I was looking for. I thought I saw that before. Okay, so now we have a root CA. Perfect. Oh, let's get this off the screen now. Hello? There you go. Let's see. Suppose this is the root CA of your organization, and then you're going to make an OpenZiti CA. And if you haven't explored the OpenZiti's controller configuration file, it has three main components of that config file: the overlay network section, the APIs section, and the signing section for identities. And that's what's called out here. So the middle one is the network components. This would be things like routers and controllers. The edge CA would be things like Ziti Desktop Edge for Windows or for Mac, or your Ziti Edge tunnel. This is, sorry, no. That's over here. This is let me rephrase. The Edge CA would be for your API that drives the client API. That's what I thought of the tunnelers. It would drive the Edge APIs, which are the client API, and that's the one that's publicly exposed that all tunneling clients rely on, and the management API. And the management API is one which you can actually take off the internet. It's the one that modifies the OpenZiti overlay network itself and is a important API. And so a best practice is to often take that particular API out of the internet and keep it from being exposed entirely from the internet, and maybe bind it to localhost or some private IP address. And then on the left-hand side over here, many signed identities. That would be the Ziti Desktop Edge for Windows, or Ziti Edge Tunnel, or Ziti Mac, or your SDK application, any of those sorts of things. All right, fantastic. Let's go back now. I don't know, maybe I'll leave it open. So we've made the CSR for the root CA. Now we're going to generate an intermediate CA. Actually, did that generate a key too? Let's look in PKI. It did. And so that act, let's go back to this. This also generated a key. Right there. I missed the key out phrase. So that's important. Usually you either have to emit the private key or you have to input it as input to the CSR request. Oh, hello, another hi. Hello out there. Let's see, we'll say hi. Hi. All right. So we do have a key that got output. That's cool. I missed that step and wondered where the key was. Now we're going to do the same thing, but we'll make an intermediate CA that's just for Ziti. All right, so let's go through, and I'm probably going to just copy the entire block. Let's take a look at this. So gen RSA, this is going to create a key that is used by OpenZiti and given to the OpenZiti controller. It's going to make a new CSR, and again creates some subject that'll go into the certificate, and then output the CSR into this location. And once that's done, it will use openssl again, x509 request in, the CA, the root CA, and the root CA key. These are the keys that will sign the CSR to produce the certificate that's signed by this particular CA, and output this cert.cert. All right, let's go ahead and run these commands. Generate our key, make a new request, and then sign that request. And out should pop this. Now if we use openssl again, openssl x509 in, and we look at this, we should see it is a certificate. And so now we can do text, yeah, and see some of the information. And so what you'll see in there is this my best org, right? That was part of the input that we gave right in here, the organization, the common name, the organizational unit, and that is shown here. And now we should see also the issuer. That's what I wanted to see. The issuer was from the other CA, the root CA that we just made. Cool. Create a network components intermediate CA. I should just leave. Can I? All right. So we've made this CA, and now we're going to make the network components CA. At this point, actually, were any of these config? Yeah. So did I skip over the conf file? I did. All right. So when we made this, when we made the intermediate CA for OpenZiti here, We also provided this, and what I was looking for is to see if there was any kind, this right here. So now we're using this node, the V3 intermediate CA, which is going to be similar to, but not the same as, the root CA node, the entry, I don't know what to call it. And what's key here, what's actually really interesting to notice, is Nenkoro chose to use a path len, which means this CA can produce no more than 5 deep other certificates. And so it's not necessary to supply this. I believe it's infinite if you don't, but setting it allows you to control how deep you can go. It is also a CA, and it should have the same sorts of key usages. And so it's very similar, but has one teeny tiny change in it, just to demonstrate that you could change this certificate if you want. All right, and you do need, I don't know, I don't know what the default is. Maybe Ruslan/Nenkoro could tell us if that is by default 5 or infinite or 0. It might be 0. It's going to be one of the two, right? I imagine it's going to be one of the two. All right, see, we made our CA, and now these are going to look a lot the same. Yeah, infinite by default. Boom. That's what I thought. Yep, cool. Okay, so now we're going to make the network components, and that's going to use this node. And oh, notice this might be why he's demonstrating here. This certificate authority will only be able to issue 1 deep, and 1 deep only. This one had 5, so you could have 5 layers deep. This one only 1 layer deep. You can only mint things underneath, quote unquote, underneath you. To go back to the topology idea, 1 underneath you. This one could go 1 layer, 2 layers, then 3, 4, 5 layers. All right, was that network CA, intermediate CA? Yeah. This one can go 5, and so this one can go 1 deep. So we couldn't create certificates anymore underneath here, so to speak. All right, and this one also digital signature, CRL sign, and key cert sign. It won't double click for me. I don't know why. That's interesting. All right, let's go back to here, and now we'll make the, did I make network components, CA, copy this block, paste this block. Actually, okay, so this one has an OU of network components. And so we can also run that same openssl command that we ran before. Where's the in this one? Well, no, I'm going to just type it, openssl x509 in minus text. And we'll see the OU is now OpenZiti Network Components ICA, signed by the OpenZiti ICA. So now we have a second layer, and we've produced this part. Okay, let's go back and look at the doc. Create an edge intermediate CA. This is for those APIs I talked about. Let's take a look at this. It probably looks really similar to the one before it. Gen RSA out, PKI 2048, 256 key, signed by a different subject. Where's the signer? Signed by is OpenZiti ICA. Yeah. Okay. So looks very similar to the one prior. I imagine the other one will look pretty similar too. Let's see if there's anything that stands out as far as differences. Key. Obviously the subject is going to be a little different than the path. And I say cert key 600, certs only. Yeah. I'll have to look at what the differences are between these two extensions that are created. All right. Let's go ahead and make this one. And then we'll make this one at the same time. All right, so now we've made these 3 layers. Create and sign an intermediate C. Did I just do that? I think I just did that one. All right. My screen is so big I don't know where I am anymore, so I hope I did that right. Let's see, create a client server certificates. Okay, so now we have built out this, and I wish I had a better diagram. Let's go back to docs. So the controller has 2 ports that are relevant and important. It has one port that is for the Edge APIs and another port that is for the OpenZiti overlay components to connect to. And edge routers also have two ports. They have ports where routers connect in between, and they have ports where clients connect to routers. And so those are the four main ports that are out there. And so we're going to need server certificates, which is what we're doing here, as well as client certificates for each of those components. And so we're making now a new key for network components. And then how we're going to use this key, I'm going to find that. Okay, so we're going to use this key to create a subject best server cert. No, okay, so it looks like we're going to probably reuse the server key insert for all of the network components. That's what it has me leaning towards. DNS components at OpenZiti, Mac OS. Oh, yeah, okay. I probably should change this, otherwise I'll have to. Do I have to add? I probably have to add localhost to this. It might be a useful little tidbit in here is to add localhost, which I think you would do by just duplicating this. Or I could add a Mac OS entry to my host file. I could do that sort of thing too. Okay, and then I'm going to make a CSR and a CSR request and sign those things, and then copy extensions. That's one I haven't seen before. These are going to be valid for 600 days, so a little over a year and a half-ish. And, oh yeah, I wanted to go look at this to see if there's anything different. Path length of 0, yep. Key sign, no. And digital signature, and where? Oh, where is the, what's the usage for digital signature? Is that what it is to be a client certificate? I think that's what it is, right? That allows you to be a client certificate, digital signature. I'm going to look that up. I don't know that one off the top of my head. I think that's what it allows. And maybe, again, Rustin, if you can confirm, that would be great. And then it's key cert sign. It's one of the, I don't know which one it is. I don't remember anymore. I have to look it up every single time. All right, well, whatever. I'll keep moving on. Let's go back to the doc itself. I got to run all these commands. Okay, everything seems to be correct. Let's make sure we have a certificate here. Okay. I run all these commands. Now I'm going to make client server certificates for the edge. I'm going to just speed it up a bit. Create a chain of CAs for network components. All right, so we're going to remove CAs, probably if it exists. Is that why? Basically regenerating it, and then cat those two files onto it, and remove this too. What's this doing? Let's see. So if it was me, I wouldn't remove it because this cat will just overwrite it. And copy this into this location. Well, I could use some explainer as to why this is doing what it is. So it cats these two certs on into a new CAs folder, and then it copies it to a different location as opposed to just emitting it straight up. Seems like we could just cat these two straight onto this thing, but there must be a good reason for it. Let's just go ahead and run that. Can't remove because it doesn't exist. If I run it again, I bet it works. Yep. All right, create a chain of certificates. So let's see, what did this do? This actually catted the root CA and the intermediate onto CAs. OpenZiti demands a whole chain of certs, not just trust anchor. Actually, that's a really interesting point. This is something that's actually changed at some point. So, and this is if you're not familiar with PKI, what does this mean? So let's go back and look at. If you're not familiar with PKI and you're still watching this, it's probably amazing. Let's see if I can find this. This is what I want. Okay, so OpenZiti demands the whole chain of certs, not just a trust anchor. That is true. A lot of times there are two different ways that you can basically identify trust. You can either start at the very tip and demand that the entire chain is delivered, or you can create an arbitrary trust anchor by just providing a file that is to be trusted. So it's one that cannot verify itself because you are simply stating that it's to be trusted by using an arbitrary anchor. And so if we were to pick the OpenZiti CA, for example, the this is a relatively recent change in like last year because OpenSSL by default actually is quite pedantic about the full chain. Prior to the C tunneler, the C SDK and the Ziti Edge tunnel, prior to that, OpenZiti did support arbitrary trust anchors. And so with the move to OpenSSL, because OpenSSL basically is very difficult about the whole trust anchor, it was just easier for us to always provide the root CA as opposed to arbitrary trust roots or trust anchors. So that is the case. Now, what is interesting to me is here we're putting it out onto this CA's PEM. What I would think instead, if I were to do this, what I would do is I would use the root CA in this way, but I would add the intermediates into the server certificate. So that the server certificate provides that full chain. You do it, and when you connect to a server, I don't have a good diagram. Where there? When your SDK connects to a server like the Edge router, you have two options. The this goes into how OpenZiti's bootstrapping works. So when you enroll your SDK and you get a new identity, that identity pulls down from a URL called the well-known CA ES. Let me find it. Let me go to SSH CD AWS and get my external ID. I can never remember what this is because it's a big long one. And then if I go to here, we go to https:// 8441/.well-known ESTCA certs. If you were to go to this location in Yorker, you would see that you get a download and it's a P7C file. And so that's a PKCS7 file. And that's going to contain a bunch of CAs. That's what's supposed to be there. And as of like 8 months ago, they're supposed to be roots only. So we at least we expect them to be roots only. They're not always roots only, but that's what we expect nowadays. That's how we try to make the quick start. I believe that's how it still works. I'd have to check that before I say that with fact, but that's how it's supposed to work. Let me bring myself back on. So, all right, I gotta rewind here. We were talking about the trust anchor. So when you enroll, the SDK goes to the controller and it pulls down this bundle of certificates. That bundle of certificates is put into your identity file, and that bundle of certificates is what starts your chain of trust. Ziti does not use your operating system's chain of trust. It has to be explicitly told that chain of trust. So that's what we're doing here. We're making that CA bundle. And in order to create the full chain, like Ruslan was saying, you have two options. You can either present the whole chain from the server, or you can present the whole chain in that CA bundle. And so there's no right way to do this, and this is kind of a spiritual debate amongst some people. But one of the ways you can do it is to put it into the certificates that the server returns. And so I'm pretty sure, like if you go to Let's Encrypt and you look at a Let's Encrypt certificate, it'll have two or maybe more certs in it. The leaf cert and then any intermediaries in there. That was a little bit of a rant, but I think that you could do this without adding the intermediate if you create the server chain with that intermediate. And so if that's not the case, if that's not what you experienced, I would think that would be a bug, because that should be what you need. Maybe the server didn't present the full chain or something, but here you can see we are creating exactly that with the intermediates in the server chain. So we cat the OpenZiti network components server cert, the OpenZiti network components intermediate CA, ICA. I just figured out what the I stood for, intermediate CA. and then the actual OpenZiti ICA. And so I wouldn't think that you'd need to do this particular one. Anyway, long tirade. This is what this Ziti TV is about, though. You're tuned in for it, so you must be here for this. All right, all right. Let's see. Create the chain of certs. So, oh, did I? Yeah, I think I ran this command. Let me go back and make sure I ran this command. And then let's run this one. And so this one's going to create a chain of certificates for network components. Oh, it's just because it's RMing it. Yeah, I would just cat it straight on top. You don't need to RM it first. This will override it every single time. I'll even prove it when I run this one, I'll run this one, and run this one. See? Just do it many times. If you use two greater thans, well, then you're in trouble. So like if you come over here and you do this, don't do that, because then you're going to be adding on top of, and you don't want that. All right, so we are chaining a chain of trust for server's edge, create a chain of certificates for sign in identities intermediate. Yep. So every time you make a new OpenZiti overlay network and you create an identity, the OpenZiti controller is going to sign your identities CSR. Part of that, if you haven't seen Andrew's amazing blog series, it's one of the very first ones that's on here, so you got to go all the way down the end. Bootstrapping trust. If you haven't read this 5-part series, I do encourage you, go look at it. It will explain this entire process, and what I was looking for is this diagram. Well, we can go back to OpenZiti's YouTube channel and find this, because that's a bug that Clint's going to have to fix. So let's see if I can open that in a new tab. No, interesting. I wonder how it has a WordPress. I wonder how it. What? I guess I got to do it this way. All right. I got to fix that link. So here's the enrollment process. You can see first step is you create an identity. That was what I just said, and that's by the administrator. And then the administrator gives you your JWT, and you enroll it. The very first thing the SDK is going to do is contact the controller. It'll open up that JWT, and it'll look at the issuer. Let me do I have one? If you haven't run Ziti Edge Quick Start, Ziti Edge Quick Start, that should be your favorite new command, because that will start a brand new Ziti environment for you that fast. Ziti Edge create identity bob -o bob.jwt cat bob.jwt. All right, so here's Bob's JWT, and we take that to jwt.io. And now we look at this. And so the very first thing that the enrollment will do is we'll open this JWT and it will look at this issuer. Because the issue, this comes from a signed document. A JWT is a signed document. It has a digital signature embedded inside of it. And that signature is signed by the certificate that is presented by the controller. And that's really important, because the first thing it does is it makes one unauthenticated, unverifiable request to the controller to actually get the certificate from this controller. It takes the certificate down. It then confirms that this JWT is actually valid, and if it is valid, it'll continue with valid, meaning the JWT is signed by the certificate, by the key that is represented by the certificate, which is the public key of that PKI. All right, I hope I said that right. I hope that made enough sense for anybody who's more pedantic about how PKI works and knows more than me. Put a chat in the comments. Tell me what I got slightly wrong there. Andrew, I'm looking at you. All right. So this URL is important. You'll need to be able to get to that URL, and you can see my Windows machine can't get there. If I were to go back to my Windows subsystem for Linux machine, do a -ks, this can get there. And so that's what's important. So now I can enroll this device from my WSL instance, but I couldn't enroll this from my Windows machine because the advertised address is not one that I can route. All right, I hope all that made sense. I went through that very fast. All right, so chain of certificates for intermediate CA. I don't know which of these I've run, so we just run them again. Actually, let's kill my instance. Kill this. All right. Run them again. Okay. Initialize an edge. Oh, we're going to look at, I did actually get this far. This is cool. Now we're going to initialize the controller right here. That's really neat. Okay. Run the controller. That is fantastic. Okay. Let's see. Ziti. I did that. Logged into the controller. I did need this window. Didn't know it. 121.1280 was refused. SS minus LNTP. Oh, it's on 2? Why is it on 2? Huh. Is that... Why is it on 2? That's very confusing. Did the initializer put it on 2? Or did CD in the controller? This is what I wanted to look at. VI, not up there, down here. VI. I'm not in the right directory. Oh, it's in temp. That's why temp. Oh, cool. No problem. Hey, it's fun, right? This is why you have somebody else look at it. All right. Should be point 2. Yeah. Cool. No problem. Well, it's useful for the stream anyway. I can go and look at my Ziti TV and see how I would debug this. I'd look at the... Okay, where is my... Oh, it's in here. No. Where did I put this thing? Where is this thing? OpenZiti temp controller. Oh, it's right there. Okay, it is there. Just didn't see it. All right, and we have an advertised address of .1 and .1, and then .2 and then .2. Aha. Okay, well that's totally fine. That's entirely a valid use case. All right. So just needed to know it was on 2, and so we went back and we ran our Ziti admin login, and it says, do you trust it? Because I've never logged into it before. I said yes, and right there, just by logging in, you know that we've succeeded, because OpenZiti won't allow you to do that if your certificate chain is broken. And so that's really cool. Let's see, enroll the router. Oh, that's it. We're down here. Boom. And then come over here. Let's do a clear. So we're going to delete the edge router if it exists. I do the same thing all the time. Ziti edge create edge router -o JWT. Give it the tunneler aspect, meaning it can route traffic and accept, offload traffic. That's the word I was looking for. And then make it public. So oftentimes when you run the quick start, this goes back to the whole authorizing of routers and identities. Oh, I bet you we're going to have to do that. And then we enroll the router. Okay. And now we run our router. But we are, and then we're almost there though. What we really need to see is we really need to see this thing work, because and I've fallen into this trap many times. And so if you're out there reading our doc and I screw something up like this, let me know, because it's very easy to do. Until you pass traffic through this, you don't know that this actually works. So we have to pass some traffic. And so to do that, let's finish. This will be great. 12 minutes. We've got 12 minutes and the rest of the hour. We can get this done. We're going to make it happen. So we are going to Ziti edge create identity Clint Ziti TV -o Clint Ziti TV. Actually, I'm going to do this in Windows. So mount C temp. I'm going to use my Windows subsystem, my Ziti desktop edge for Windows. Now, those astute among you should know this is not going to work. Or maybe it will. Maybe Windows is good like that. Clint Ziti TV. Okay, failed. I expected it to fail because I expected this JWT to have inside of it something that I'm going to have to go and just add to my hosts file, which I will do. So when that fails, the first thing I do is I open that JWT. You can be... You can paste it into jwt.io if you want. They tell you, we're actually just using local JavaScript for this. But if you're really paranoid, don't put your JWT into the internet. It is a key. It is a secret. You should not give it to anybody unless you've used it. Once you've used it, obviously it doesn't matter anymore. So I need to be able to get to this URL. And because this is Windows subsystem for Linux, it's not going to work for me. So I'm going to enroll it right here. Maybe what I'll do is I'll cd to Ziti and then I'll cd to SDK Golang. No, cd to SDK Golang, cd to examples, and I'll look for one of these. Maybe we'll do, what's the one I use all the time? Reflect. I like the reflect. cd reflect, and then we run, actually, let's look at the README on this one real quick. So SDK Golang, and go to example, and go to reflect. All right, requirements, yep, build the example setup, yep, okay, already logged in, do this. Let's see how good this example is. We're doing it live. Okay, did a thing, spit out the policies. Yep, perfect. That's actually really smart that we did this, because this is a step I thought we were going to. So if I do a Ziti edge list, let's spell it out, edge router policies. Right now, I have one edge router policy that lets one identity talk to one edge router and nothing else. Again, zero trust, all about full authorization. If you run a quick start, the quick start makes this policy for you. So if we go back to that from scratch URL that we looked at before, where was it? That's not from scratch. Oh, that's the actual, this is actually the discourse link. Where is the from? There it is, right here. No, where's the actual discourse link? From, all right, I know it's under my, it's a gist, isn't it? Boy, from scratch. I thought for sure, is there a gist right here? There it is, all right. Policy, no, ERP, all, that's what I want to look for. Okay, so it doesn't show up here. So let's look at, I'm going to go back to the docs. I'm going to go to quick starts. I'm going to go to network and host it anywhere and find that SH again. And we're going to look at that SH. And in here, I'm going to look for the word all, because let's look for the word pound all. Because in the quick start, what you'll see is you need to make a policy that gives your identities access to that router. And so in the quick start, it runs Ziti edge create, actually, sorry, let's make it bigger so it's easy to read. Ziti edge create edge router policy. All edge routers means every public edge router is available to all identities. And so if you recall back where we made our router before, I don't remember where that was in our doc journey here. Over here. Nope. How about over here? Yeah, here, where we made our edge router, we gave it an attribute of public. So if we do a Ziti edge list ERs, we'll see we have one test edge router with an attribute of public. And so now, if I do a Ziti edge create edge router policy, all edge routers, then I do an ERPs. You can ERPS or Ziti edge list edge router policies. Same thing, ERPs or edge router policies. You see now all identities have access to the public routers, and we only have one router and it's public, so basically it's all to all. But notice this, see this, remember this? It said your Reflect client and server have access to no routers. If we run that policy advisor again, where is Ziti? I'll just type it. Ziti edge policy advisor, identities, and then -Q. And then I wonder how we ran that. Let me actually, now I want to know. I didn't know I could do that. That's actually cool. Policy advisor services. Okay, that's why. All right. Service has no edge routers assigned edge router policies. So we're almost there, but the service has no edge routers assigned. Did it say that before? And I just skipped it, thinking that it was. Yeah, I was thinking that it was the same thing before with edge routers. So if I did identities and then do reflect client, and I always pass -Q because I don't want to see this. Service has no edge routers. Service, they must just print that out first. You also have to do this for service edge router policies, is what I was getting at. Those of you might have noticed there's this other one down here where you create a service edge router policy. This grants services the ability to use edge routers. What's important there, and then which is difficult, and I strongly urge you to have an all service edge router policy until you know better. But what that means is every router on your network can either onload traffic for that service or offload traffic for that service. Nothing in between is important. Only the onboard point and only the offload point. So if you don't have this service edge router policy, you also won't be able to use services. So we need to make that as well. Now, when I run the policy advisor services -q, we should have joy. Hey, okay, look at that. All right, so now we have, and if I deleted Ziti edge, delete DELETEERP, what did I call this one? All ERPs, yeah, all edge routers. And then I run policy advisor. Now the identity has no routers assigned. And so it does only print one error at a time. Let's go back and create the edge router policy. Create, where is it? Where is it? Create edge router policy, run the policy advisor. Now we're okay again. All right, cool. So go back to here, run the reflect server. Oh, I did all this in the wrong directory. Well, that's a bummer. All right, let me cd to Ziti, cd to SDK Golang, cd to example, cd to examples, cd to reflect, and then go build /./.o. Actually, you gotta do it over here. -o build. We'll build all these things just to prove that I'm going to do this right now. All right, we're almost done. I promise. I'm feeling it. I'm feeling it. But until you pass traffic, that's how you know it's done. All right, build, and then we'll run the reflect server, and then we'll give it the let's see, home $home, and then reflect service. Okay, I already know it's going to work because it allowed me to establish a session. But let's just take it on home, go out with a bang, make a new window here. CD there, and then we'll do the same thing. Server, home, reflect server. It's going to be client.json. Boom. And then service ID, service not found. Oh, did I screw something up there? Oh, I ran server. Let's run client instead. I should have just copied and pasted from the other thing. Hi there. Hello, I am the server. Got a little buffer action going on, but you see, hi there, I am the client. I don't know if there's a bug or what. Fantastic. We fit it all in an hour. I mean, that's exciting stuff. So what did we do? We actually went a little above and beyond. We took a look at Ruslin's really amazing. This is not it. That's our SDK. That is not it. I'll get there. We'll get there. All right. We took a look at Ruslin's or Nankoru's really amazing OpenZiti manual PKI guide. Really suggest checking it out, giving it a try, learn some openssl commands, take a look at what he did and how he did it. Even went so far as to provide you the commands to start your OpenZiti overlay network. Like super extra codes on that. Nicely done. Might be useful to add the little extra bit at the end to show people how to do it, either using a tunneler or the SDKs or whatever people make their boat. But like, this was great. Really impressed. Awesome stuff. Appreciate you sharing this on a Friday, giving me a good Ziti TV thing to do. And I mean, I had a lot of fun doing it. I hope you guys enjoyed watching it. That'll be the stream for this week. Hopefully we'll have one next week, or just subscribe. Oh yeah, right. We've got to like and subscribe and all that sort of stuff. Don't forget to give OpenZiti manual PKI a star. Still only see 2 stars on there. That means it's just me and this other random fella who found it too. So go give it a star, and then don't forget to give OpenZiti and Xerox stars too. All right, everybody, that'll be the end of the stream. Have a nice